Quantum computing is one of the most exciting and revolutionary technologies of our time, but what exactly is it? And why is the whole world suddenly talking about it? In this video we're going to break it down in the simplest and most engaging way possible so that anyone, even with no background in physics or computer science, can understand what quantum computing really means and why it has so much power to change the future. To understand quantum computing, we must first look at how today's classical computers work. Every phone, laptop, and supercomputer on Earth uses information in the form of bits. A bit is like a tiny switch that can be OFF or ON, represented as a 0 or a 1. Everything you see on your screen, every video, photo, message, and program is processed using billions of these tiny switches turning on and off extremely fast. For decades, this system has worked beautifully, but classical computers have a limit. No matter how powerful they become, they can only process one possibility at a time. Quantum computing challenges this entire model by introducing a completely different type of information unit, the qubit. A qubit is not limited to being just 0 or just 1. Thanks to a quantum property called superposition, a qubit can be 0, 1, or both 0 and 1 at the same time. Imagine flipping a coin and watching it spin in the air. While spinning, it is not fully heads or fully tails, it's in a combination of both. That's what a qubit is like. Because of this, a quantum computer can process many possibilities simultaneously. If a classical computer is like reading a book line by line, a quantum computer is like reading every page of the book at the same time. That alone already makes it extremely powerful, but there is another quantum property that makes it even more astonishing: entanglement. When two qubits become entangled, they form a special connection where the state of one qubit instantly affects the other, no matter how far apart they are. Einstein called this phenomenon spooky action at a distance, because even he found it unbelievable. This connection allows quantum computers to process information in ways classical computers can never achieve. But how does this make quantum computers faster or more capable? Let's take an example. Imagine trying to find one correct key out of a billion keys. The classical computer would check one key, then the next, and so on extremely fast, but still one at a time. A quantum computer could check many possible keys simultaneously because its qubits can exist in multiple states at once. This is why quantum computing is so powerful. It doesn't just do the same thing faster, it does something fundamentally different. It explores many possibilities in parallel instead of one by one. This power opens the door to solving problems that classical computers might take thousands or even millions of years to solve. Quantum computers could transform industries in ways we've never seen. In medicine, they can simulate molecules and chemical reactions at the quantum level, helping scientists discover new drugs much faster. In finance, they can model complex markets and risk systems in ways classical computers struggle with. In cybersecurity, quantum computers can potentially crack many of today's encryption systems, which is why governments and tech companies are racing to create quantum-safe encryption. In artificial intelligence, quantum computing could speed up machine learning processes and allow new types of AI models that were previously impossible. In climate science, quantum computers could simulate the atmosphere, weather, and climate patterns with unprecedented accuracy. For engineering, they could help design new materials, batteries, and energy systems by simulating atoms and molecules directly instead of through approximations. However, quantum computers are not simply better than classical computers. They are different. They excel at very specific types of problems, especially those involving enormous combinations, patterns, or simulations. For everyday tasks like browsing the internet, editing videos, or playing games, classical computers will still be used. Quantum computers are extremely delicate machines. Qubits can lose their quantum state very easily through heat, vibration, or electromagnetic noise, problem called decoherence. That's why many quantum computers must operate at temperatures colder than outer space, close to absolute zero. Because of this, building a stable and reliable quantum computer is one of the hardest engineering challenges in the world today. Companies like Google, IBM, Microsoft, Amazon, Intel, and many startups are investing billions of dollars to make quantum computers more stable, with more qubits, and with lower error rates. Despite the challenges, progress is happening fast. Some quantum processors have already reached hundreds of qubits, and researchers are constantly working on new techniques to improve reliability. The race to build the first fully practical quantum computer is often compared to the space race, a competition that will shape the future of technology, science, and global power. So when someone asks, "What is quantum computing?" the simplest answer is, it is a new way of computing that uses the strange and powerful laws of quantum physics to process many possibilities at the same time, solving certain problems much faster than classical computers ever could. It is not just a faster computer. It is a completely different computer, and we are only seeing the beginning of what it can do. The future powered by quantum computing is going to be more advanced, more intelligent, and more capable than anything we have seen before.